All right, welcome back, guys. We are going to work on lesson 8.3. We looked at proving triangles similar by angle-angle similarity. Today, we're going to look at two other ways of proving triangles congruent, side-side-side similarity and side-angle-side similarity. So let me present my screen. Oh, push the wrong button. Present screen. Here we go. Okay, so we do have some vocabulary to start with, and as I've been doing for this chapter, I'm going to use your textbook, and you guys can copy this down into your notes. If I'm going too quickly, you can always stop the video for a second to copy down the vocab and then keep on going. Okay, some of these words, again, are repeats from lessons 8.1 and 8.2 because I really want you to know the terminology. All right, so similar figures, geometric figures that have the same shape, but oh my goodness, not necessarily the same size. Okay. So again, geometric figures that have the same shape, but not necessarily the same size. Okay. Corresponding parts. We talked about this one as well in our last lesson. Corresponding parts. A pair of sides or angles that have the same relative position in two congruent figures. Okay, so in our similar triangles and our similar figures, our angles are corresponding and congruent. Our sides are corresponding but proportional. They're not congruent. Next, we have slope, which is a term we know from Algebra 1. Slope, the rate of change between any 2 points on a line. So when we hear slope, we think rise over run. We think change in y over change of x. We think y2 minus y1 over x2 minus x1 because that is the formula for slope. Again, pause if you need to pause to write any of this down. Next, we have parallel lines. Oh, where are my parallel lines? I went too far. Parallel lines all the way up top. I totally missed them. All right, two lines in the same plane that never intersect. And if you look at the example, parallel lines have the same slope, but different y-intercepts. And that's important. Okay, so same slope, but different y-intercepts. And then we have perpendicular lines. Oh, went too far again. Perpendicular lines are two lines that intersect to form a right angle. Okay, so we know the symbol for perpendiculars is upside down T. Line M is perpendicular to line L. Okay, and you can see right angles are being formed right here. Right angle here, right angle here, right angle here, and right angle where the box is. All right, so that is it for the vocabulary for that lesson. Again, if I went too fast, pause, rewind, whatever you need to do to get those into your notes. All right, so we have the side-side-side similarity theorem. And this theorem tells us that if the corresponding sides of two triangles are proportional, then the triangles are similar. So you might be given two triangles. You are going to be given in just a second in the first example. You're going to be given triangles, and maybe they tell you the side lengths of the one triangle are 2, 4, 6, and 8, or that would be too many sides, 2, 4, 6, and 8. That wouldn't be a triangle. 2, 4, 6. There we go. And then the sides of the other triangle are, let's say, 4, 8, and 12. And if I want to know if these are similar triangles, I'm going to set up the ratios and see if they simplify down to the same scale factor. So if this side corresponds to this, I'd say, okay, 2 over 4. And then this side corresponds to this one, 4 over 8. And this side corresponds to this one, 6 over, and since they all simplify down to 1/2, 1/2, 1/2, that means that they are similar triangles and the scale factor is 1/2. Okay, so that's the kind of thing we're going to be looking at when we're using the SSS similarity theorem. All right, so in example 1, basically doing what I just explained. Now, the nice thing here is they already stated the triangle's names. They want you to check to see if triangle DEF is similar to triangle ABC or if triangle GHJ is similar to triangle ABC. So the order of the letters kind of already tells us which sides and angles match up to one another. They also very nicely used red to show you which sides correspond. Now, let's pretend for just a second that this information was not given. They didn't state the triangles. And let's pretend they used black ink for everything, okay, instead of using colored ink. How would you know which sides match up? Okay, and I tried to explain this, I think, in the first lesson. Well, if this was the situation, I just said to you, is this triangle similar to this triangle? I didn't name the triangles. I didn't use nice colors, so you wouldn't know. What you do is you pick the smallest side of this triangle and you compare it to the smallest side of this triangle. So I would set up the ratio 8/6. Then I go to the medium length here, which is 12, and the medium length here, which is 9, so 12/9. And then I would go to the longest side, 16, and compare it to the longest side, 12. Okay, now we don't have to do it that way because, like I said, they were very nice and highlighted and already named the triangles for us. Okay, now if I simplify, they are both divisible by 2, so that's 4/3. And they are both divisible by 3, so that's 4/3. They're both divisible by 4, that's 4/3. Since they all simplify down to the same value, that means that triangle ABC is similar to triangle DEF. And it's by side similarity. Now, the scale factor, if I'm going from this triangle to this one, all right, the scale factor would be 3/4. If I'm going from this triangle to this one, the scale factor would be 4/3. Okay, I don't know what scale factor they want. I don't know which was the original, which was the new. Okay, all right. Then we now want to compare and see if this triangle is similar to this one. Okay, you're asked to do that one as well. So again, you can use the letter and know that which sides, sorry, I'm looking here now, which sides match up based on the order of the letters. You just look at the colors or small, small, medium, medium, large, large. It's up to you. Okay, so 8 to 8. All right, then I'm going to go to the green. So I'll do 12 to 10. And then the blue, 16 to 16. So here I have 1/1. Here I have, let's see, they're both divisible by 2, so 6/5. And here I have 1/1. Okay, they are not all equal to each other. So triangle ABC is not similar, so similar with the line through it, not similar to triangle GHJ. Okay, so that is example 1. Example 2. Find the value of x that makes triangle. Oh, I don't know what that is. All right, find the value of x. Still don't know what that is. That makes triangle ABC similar to triangle DEF. Okay, so if we want the triangles to be similar, that means the sides need to be in proportion. Okay, and I could write an extended proportion if I want to, just to get started. I could say that side AB corresponds to side DE, excuse me, and side BC corresponds to side EF, and side AC corresponds to side DF. And if the triangles are similar, they're all equal. Now fill in all the numbers. AB is 4, DE is 12, BC is x minus 1, and EF is 18. AC is 8, and DF is 3 times the quantity x plus 1. Now, this is an extended proportion. You're just going to choose part of it, either this part here, right? So you could write that proportion down and solve for x, or you could write this proportion down and solve for x, or you really actually could also set these two equal to each other and solve for x. It's up to you. You don't need to do all three. You just need to choose one. I'm thinking the one in the red box is probably the easiest to solve. So I'm going to write it over here. 4/12 is equal to x minus 1/18. Now, you can just do cross products from here. Or if you want to simplify this first and make it 1/3 is equal to x minus 1. Okay, the more simplified you simplify your fractions and ratios, the smaller the numbers, the easier the math. So now I'm going to cross multiply So I have 18 is equal to 3 times the quantity x minus 1. I would not distribute the 3. Instead, I would just divide both sides by 3, right? The goal is to solve for x, so divide both sides by 3. So 6 equals x minus 1, and then add 1 to both sides, so x equals 7. Now, if you chose to use the proportion in the yellow box, you're still going to get the same answer. If you chose to set 4x equal to 8 over x times the quantity, 3 times the quantity x minus 1, you still would have gotten the same answer. Okay? All right. All right, then we have the side-angle side similarity theorem. The side-angle side similarity theorem says that if you know an angle is congruent to an angle, and if you can show that the two sides that include that angle, so this side, and then this side and this side, if you can show that those two sides, because they're the two sides that make this angle and this angle the included angle, if you can show that the red side is proportional to the red side, the yellow side is proportional to the yellow side, then you can say that triangle XYZ is similar to triangle MNP by side angle side similarity. Again, the sides aren't congruent, they're proportional, but the included angle is congruent. All right, so let's use that now. So for example 3, it says explain how to show that the indicated triangles are similar. So as soon as I see that I'm given a side, an angle, and a side, and I'm thinking side, angle, side, but I need to show that the sides are proportional, okay? So I could first start by saying that angle R is congruent to angle N. That's good because you do need an included angle being congruent. And then I want to show that SR to N or PN is equal to RT over NQ. That's what I need to show. Okay, so let's set it up. I should have written smaller because now I'm running out of room. I'll have to do it over here and then erase. So I have 24 over 18. Is that equal to 28 over 21? All right, 24 and 18, both divisible. Oh, excuse me, my eye's itchy. Both divisible by 3. 3 goes into 24 8 times. 3 goes into 18. Oh, shoot. Hold on. Did I use the wrong numbers? No, I'm just not doing my division correctly. Both are divisible by, why can't I think in my head? Oh, 6. Oh, my goodness, guys. I think it's getting too late for me to be making videos. 24 divided by 6 is 4. 18 divided by 6 is 3. All right. 28 and 21, both divisible by 7. 7 goes into 28 4 times. 7 goes into 21 3 times. Okay. So I have that my sides are in proportion. They simplify down to the same ratio. Okay. So that's how I know that the triangles are similar by side angle side similarity. Okay. For the next example, you're asked to show the triangle XZW, this one here, is similar to triangle YZX. So it might be a good idea to redraw the triangles and orient them the same way on the paper. So here I have XZY, Y, with my right angle here, okay? And I have 15 units, 12 units, and 9 units. All right, and then I have triangle. I want to orient it the same way. All right, so let's see. Y, Z, X. So it's going to be X, Z, W. Right angle here. All right, so WZ, how long is WZ? 16. And WX is 20. And then 12. Okay. So I can see that I have an angle congruent to an angle. I need to know whether or not this side is proportional to this side, and if this side is proportional to this side. I don't really care about the third sides because those aren't the two sides that make the included angle. Okay. So I really just need to check, is WZ to XZ proportional to ZX over ZY? So I have 16 over 12. Is that equal to 12 over 9? All right, 16 and 12 both divisible by 4. I'm going to have to do my work over here. So I have 4 over 3. 12 and 9 both divisible by 3. 4 over 3. So again, they are proportional. So the triangles are similar by side, angle, side similarity. Okay. All right. Let me see. If I go to the next page, I think it's just a quick overview. Yep, in this box, it's just a nice kind of quick overview of the 3 theorems we've talked about so far to prove the triangles similar. So again, we have AA similarity. 2 angles of one are congruent to 2 angles of another is enough to prove the triangles are similar. We have side, side, side similarity. All 3 sides of this are proportional to all 3 sides of this one. Or side angle side. The included angles are congruent, and then this side is proportional to this one, and this side is proportional to that one. I don't care about the third sides in this example. Okay. All right, guys, that is it for lesson 8.3. I'll see you back here for the next one. Bye.